we're talking about properties of numbers right now, which there's not really any work to do. It's just identifying different properties that are used when simplifying a problem. Properties are just rules that you have to follow in math, and some of them are really, really dumb. It's kind of like a mathematician was just bored one day and wanted to be popular somehow, so they made up a name for something stupid. But anyway, you should have talked about the commutative property and the associative property last year. We're not going to focus on those. I'm going to show you a few more. And knowing how to use properties is important for once you get to geometry. But the reflexive property is just saying that a number is equal to itself. So example, 5 is equal to 5. That's pretty obvious. They just gave a name to it. They chose reflexive since when you have a reflection of something, it's the same thing. Symmetric is just saying you can switch the sides of the equation and it's going to be equal. So the example I wrote here was 8 equals 2 plus 6, which means also that 2 plus 6 equals 8. To think about this algebraically, you could also think if 2 equals x, then you could rewrite that as x equals 2. So it's just saying you can flip the sides of the equations around and it's still going to be equal to each other. The transitive property, it's trickier than all the others, and you will not be using the transitive property this year. I just wanted to introduce it, but it's more of a geometry thing. But it's just saying, let's say for example we had 6 plus 9 is equal to 3 plus 12. And then you were also told that 3 plus 12 equals 15. We can assume that the first part, that 6 plus 9, is also equal to the last part, 15, which we know is true. 6 plus 9 is 15, but it's just saying the first part of something is equal to the last part of something. Substitution, I think of this just as simplifying. So anytime you're just simplifying part of the problem with just normal numbers, we're going to call it substitution. So an example I wrote here was, let's say that n equals 11 and you wanted to solve for n. So we just plug in 4 times 11 to get 44. So we're just solving a problem, and that's it. The rest that we're going to look at, they look closely at ones and zeros. So if you're adding 0, multiplying by 0, multiplying by 1, then it's not going to be substitution, it's going to be one of these special properties. The additive property just says you can add 0 to anything and it's going to equal whatever you started with. So 2 plus 0 is equal to 2. So adding 0 does not change anything. The additive inverse, first we're looking for addition, and inverse means opposite. So we're adding the opposite of a number. So over here there's an example, 3 plus negative 3, so 3 plus its opposite, it'll give us 0 every time. Now we can also think of this in terms of subtraction, where 4 minus 4 equals 0. The reason why that works is we can write 4 minus 4 as 4 plus negative 4, and it's still going to give us 0. So since you can rewrite subtraction as an addition problem, if you're subtracting the same number, that's going to count as an additive inverse. The multiplicative identity just means that you can multiply anything by 1 and you're going to get that same number. So the example I wrote out here is 14 times 1 is 14. Next is the multiplicative property of 0, which just says that you can multiply anything by 0 and get 0 as your answer. The multiplicative inverse just says if you multiply by its opposite, you're always going to get 1. So for example, 4 fifths times 5 fourths, that's 20 over 20, which is equal to 1. So a lot of different properties. I will tell you, you are not going to use these top 3 this year, but you will use these bottom ones. And substitution is going to appear more than anything else, just because it's a more broad property. You can do more with it. So we're going to look at an example down here. So it wants us to name the property that's happening in each step. For some people, it's easier to think of this as looking at the line above what you're trying to find. So some people like to just focus on this line when they fill out this blank, which is fine. But what I do is, this is the original problem, this is where they went. So I need to see what change did they make. Well, they said 15 divided by 3 is 5. 15 divided by 3 equals 5. It's just solving part of the problem. It doesn't include any zeros or ones or inverses, so it's just going to be substitution. I'm going to abbreviate that. Next, they said that 5 minus 5 is 0. So the property that told us that if we take a number and subtract it by itself to get 0, that was the additive inverse. So again, it's the additive inverse, but we can rewrite subtraction as addition, which is why that's fine. Next, they said that 7 times 1/7 is 1. So this is 7 times its opposite, equaling 1 is going to give me the multiplicative inverse because we are multiplying by the opposite. The next thing that's happening is 6 times 0 is 0. So anytime something times 0 equals 0, that is the multiplicative property of 0. And then last, 1 plus 0 is 1. So anytime you add 0 to a number and you get it itself, that's just the additive property. You can also put additive identity. Property and identity, you can switch them up. It makes no difference. I will tell you that you can reuse some of these properties in the same problem. So sometimes you might have substitution 2 times in a row. That is perfectly okay. You just want to be careful, look closely at what's happening between each step and match it up with one of our properties. If you have any questions, please feel free to email me.